Okay, so let's kick off functions, but this is kind of a bit of a backup video in some ways, so it will be a straight up video. Get ready to pause and let us make it maths. Okay, so here we are with, with functions going on, and inverse, exponential, logarithmic is what's coming up. And your question is, what is a function? And of course I'd go, what is a function? What do you think? But for this one, we're just going to keep it simple and say, well, let's just draw some things on a set of axes, and we're just going to look at it quite simply to start with. We're not going to go into function domains and ranges and mappings and all of that. Just going to say, you know what, let's just take some sort of line on the Cartesian plane, doesn't matter where, and say, sure, I wonder, there's a line on a Cartesian plane, is it a function? And the way we're going to check that is quite simply, can we draw a vertical line where it only intersects that graph once? So let's do this, right? I like doing this. So if we draw a vertical line, only going to touch the graph once, let's keep going, only going to touch the graph once, no matter how far we go, we're only ever going to touch that graph once. So what I mean by that is draw a very vertical line like mine, and no matter where you draw it, it's only going to cut it once. So therefore, function. For every x value, there's only one y value. Now let's draw another one and say, what about this one? Like, obviously I'm going to draw one that's not a function, right? And I'm going to go, here we go, and it goes whoop-de-doo, comes round about like that and does that, and we go, oh, is that a function? Well, we easily draw our line. Let's do it like this now and say, well, I'm going to pick over here and go, look, it's cut the graph more than once, and therefore not a function. So, not a function. There's some point where on this one, where we can draw our vertical line for the x value. Here there are multiple y values. Okay, so that's our quick thing, vertical line test. We're going to keep revisiting that as the section goes. So visually, all about the vertical line. Now for this video, I want to kind of quite quickly go for drawing a few functions, just to get ourselves back into drawing functions like we did in grade 11. So f of x equals 3x minus 12. Of course, the question you're asking yourself is, what type of function is this? Well, it's a straight line, right? So you merely went, okay, well, let's draw ourselves a nice set of axes, x, y, and say, how do we draw this function? Well, we remember there were these things like this bit here was m, which represented our gradient. This bit here, the 12 helped us to, or the negative 12 I should say, helped us figure out that the y-intercept is 0 minus 12. So we go, oh, well, with that, we already know it goes there. It's a positive gradient. It's fairly steep. So we're going to do that and say, okay, well, that part, 0 minus 12. Big fan of putting full coordinates, not just minus 12. And then we go, we need to work out this point. And we went, well, we could either just sub in. So we went, okay, well, at this point here, we know that y is 0. So 0 equals 3x minus 12. And we merrily solve that and go, therefore, x equals 4. So we put a 4 in there. Or you went, oh, well, gradient's 3. So for every 1, you're going across by 3. So it must have been 4. That's like going way back now. So straight line's cool. Then we've got parabolas. And you're like, oh, this was our basic parabola, right? So we went set of axes, x and y. And we're like, cool, well, let's just draw that. I'm just going to draw it straight up. It goes like this. It's our most basic parabola. And I guess it would be nice to label it y equals x squared, or g of x equals x squared, or just call it g. And this point here is on the origin 0, 0. Most basic parabola. Cruising along, pause if you need to, but I mean, these are the ones we've seen a while now. Oh, and then we went x squared minus 16. Okay, so set of axes for this type of thing we said, well, this is like our basic parabola, except this bit here, this is like our Q value, and this meant that it moved down. It had a vertical translation or shift of 16, so I'm going to kind of double that up and say it's gone down by 16, or it's shifted vertically, negative 16. So therefore, it's now got an intercept at 0 minus 16. If we subbed in 0, we'd see that too. And I'm whizzing through this because this is what we did a few of. And we're like, okay, how do we work out these things again? Well, we know y is 0, y is 0, so we subbed in 0 equals x squared minus 16. It's a quadratic. We factorize x plus 4, x minus 4. So x equals minus 4 or x equals 4, which means we worked out that minus 4, 0 is a point, and 4, 0 behind my head is a point, so minus 4, 4. Right, again, just a little tidbit. I like these two bits to finish off with full coordinates. We don't have x is minus 4, 4. What did that mean again? Coordinates, and then that way, right? Off into our graph it went. Cool. Onwards, upwards to our next one. Another parabola, but this time in turning point form. So we're like, cool, let's draw a set of axes, x and y. There it is, there it is. Now, this time we saw, okay, well, this bit here, this helped us with our this is turning point form. So minus 3 meant that we were going, okay, let's just do that. So this, we're going x minus p. So this is p, our turning point. And this part here, plus q, is our other part of the turning point. So this turning point is 3 minus 1. So just be careful, it's not negative 3. We're subtracting 3, the x value here. And you might not have been given it in a turning point form, and you did some magic like minus b over 2a and all of those things. But we know that it's at 3 minus 1. Okay, so like about there. We know that it's a happy parabola because it's positive. Maybe it would be worthwhile seeing, I wonder, there's definitely an intercept here, but it's not immediately clear if the graph goes like this, if it goes like that. So let's maybe just work out the other x-intercept. Well, easy, y equals 0. So we can sub in, or we could move this graph across. So those are our two options to go, well, we know this point here, 3 minus 1. Now, one option to find the x-intercepts is to go 0 equals x minus 3 squared minus 1. Definitely a foolproof way of doing it if your algebra is feeling strong. You're like, 0 equals x squared minus 6x plus 9 minus 1 still. 0 equals x squared minus 6x plus 8. That I can factorize. 0 equals x behind my head. That little thing's irritating me. I think I can move it. Not quite. Okay, so here we've got x and x. We got minus 4, minus 2, so x equals 4, or x equals 2. Okay, so what we worked out is that we've got these two x-intercepts, right? Those are too terrible, but, you know, we go there and we go, But, of course, what we could have done, so this part here was 2, 0, this part here is 4, 0. We still need to find the y-intercept. Well, maybe we should have started with that, because then we would have known where this graph was going to go. So we're going to sub in 0. So let's do it. Where can we squeeze it in? Down here. G of 0 equals 0 minus 3 squared minus 1. Minus 3 squared, 9, 9 minus 1. 8, does that seem about right? I just need to double check myself on these ones. 9 minus 1 is indeed 8. So if we subbed in x is 0, then down there, what do we get? 0, 8. So this part here is 0, 8. My graph's not very to scale. Okay, they are all our interesting points, turning point, things like that. Okay, as I said, this whole mess over here, I'm not going to do it in this video, we could have figured out by going, oh, well, it's been translated 3 to the right and 1 down, and our x-intercepts were kind of 1 across from each side. As I said, let's just maybe just slog through the algebra. Okay, onwards, upwards, let's go for it. Example 5. Another parabola, because of the x squareds here. And so we've got x, y. Now, this one I kind of just threw in because it's actually in turning point form. Right? We're adding 0 over here. So our turning point is 2, 0. So we've got a turning point here on the axis. So that's, a little bit interesting, but we might not have spotted that it was in turning point form to start with. So this point here is 0, 4. This point here is 2, 0. Okay, so just a reminder that that thing there was a nice turning point form. Quick and easy to sketch, actually. Remember, the 2 was there. For this part, I just put in f of 0 equals 0 minus 2 squared. Minus 2 squared is 4, which gave us our 0, 4 point. Okay, so there we are. Actually a simpler one than the one above. Not too much algebra or anything to work with. And, we are flying through this, aren't we? A little bit scary. H of x equals 1 over x. Oh, I remember these. These were hyperbolas. So, there we go. Now, with hyperbolas, there were all sorts of things going. We've got the hyperbola, this kind of most basic standard one, was in the first and the third quadrant. Carries on forever. And there were these exciting things called asymptotes. So our asymptotes, I'm going to draw with blue kind of dotted lines to go. There's an asymptote there on the axis. There's another one there on the axis. And there's our graph. So maybe let's just remind ourselves about these asymptotes. They were at here on the x-axis. That's where y equals 0. And the other one at x equals 0. And these points, and there were, axes of symmetry and all sorts of exciting things. Okay, I think we've got a couple more to finish us off here. And we've got, another hyperbola, but this one looks a little bit more exciting. So, shame. The other one was very exciting as well. So, x and y. What do we got here? So, again, we've got this idea of minus p plus q. So that point there is kind of where the asymptotes meet. So this one's at 3 and minus 1. Hey, it's like the other one. Which means there's an asymptote there at x equals 3. Because we can't have 3, because then we'd have 3 minus 3 and we'd be dividing by 0. And then we've got this other one at minus 1. So I went over the dot I put earlier. I think I got it there. Y equals minus 1. And then we look at this and we go, oh, this part over here, let's throw it in here. This is positive, which means that we're in the kind of we're thinking first and third quadrant. Of course, it's going to have translated, but we're thinking it's kind of that shape and moved around. So we know that it's over here and down here. And I mean, if in doubt, we're going to need these two intercepts. So let's just look. This one we know the x value is 0. So if we sub in 0, f of 0 equals 6 over 0 minus 3 minus 1. So minus 2 minus 1 minus 3. In other words, 0 minus 3. It's fitting in with our idea. Because look, 0 minus 3, that needed to be below the asymptote. Wouldn't have made sense to be above. So it fits the shape that we thought originally. And I say that because maybe you go the other way around and find this point, and then you can fit the shape afterwards. They'll work nicely together. And here, this is 0, so we can go 0 equals 6. So this here was for the y-intercept. And this one here is for the x-intercept. I don't know. That says intercept. And we've got x minus 3 minus 1. Feels like a little bit more work, not too much. So let's do that, and I was making things worse here. Oh, I don't know. Anyway, so let's just carry out with this and go, okay, well, 1 equals 6, x minus 3, x minus 3 equals 6, x equals 9. Yeah, that kind of fits in with what we thought there, so that's terrible. 9 and 0. Okay, so let's just check that we're on track there. X minus 3 times, yeah. So x equals 9. Remember, I like to finish it off there. So there we go. There's a whole lot of work to get our hyperbola. And that is it until we do inverse functions next. So that was what do we want? Less than 16 minutes to really, really quickly go through lots of functions that I hope you're hitting pause to scribble everything down as we go along, because that's going to take a good 30 to 50 minutes in the classroom, I'm sure. You know what? Remember to make it maths.